Someone on Reddit saw this building being demolished and thought, hey, this is a pretty tall building. Why is it that the columns, as they get closer to the base, are getting skinnier? Shouldn't it be the opposite? Well, let's discuss the structural engineering behind it. Let's go. These are what we in the biz like to call pre-engineered metal buildings. Oftentimes, these will be used in industrial applications because they're very good at creating large, open, covered areas without the need of columns that are all over the place. Now, each individual frame is called a portal frame, or otherwise known as a moment frame. Portal frames do an excellent job of utilizing as little material as possible to achieve the desired design by adjusting the geometry along the length of that portal frame, specifically in locations where they will encounter high stress. Depending on how the frame is designed, you can have different high stress locations, but oftentimes you will find them in the corners of the frames, as well as the midspan of the frame, and potentially at the base of the frames. Now, the reason why these columns actually get slender down at their base all has to do with the lateral design of these portal frames. You can have what's called a pin base portal frame or a fixed base portal frame. A fixed base condition means you're working with 4 joints, one at each of the bottom of the columns and one at each of the top of the columns to the beams. But when you're working on a pinned base condition, you now only have 2 joints that you can rely on to combat lateral forces. It means that the joints at the tops need to grow in size significantly to be stiff enough to combat all of the lateral force seen by the frame. Deeper members are one way to effectively increase the stiffness of your joints, and this is what portal frames actively do. And so in our original photo, this is a little trick of the eye. It's not that the column is the correct size up at the top of the structure and getting skinnier as it gets down to the base, but rather the opposite. The column is the correct size at the base to handle all of the gravity load that it's seeing, aka supporting the building's weight, but as it moves up to the joint at the top of the column gets wider to create a stiff joint to combat lateral forces. And from what we learned here today, we can deduce that this is most likely a pin-based portal frame.